In the last video, we started building the brain for our AI fighter. Right now, the AI can measure the distance to the player and attack when the player gets too close. In this video, we're going to take it a step further. We'll make the AI actively chase the player, improve combat interactions, and start building a more complete fighting system. At the moment, our AI just stands still and waits. Let's fix that by giving it the ability to move toward the player. This is where the Nav Mesh Bounds volume comes in. This volume defines where the AI is allowed to move. After placing it in your level, press P on your keyboard. You'll see a green overlay showing all navigable areas. Next, open up your AI Fighter Controller blueprint. Inside, add the On C Pawn node. From there, cast to your player character, BP third-person character, and store that result in your Blackboard key called Target Actor. So now, whenever the AI sees the player, it updates its target, and the behavior tree can react to that. Now head over to your behavior tree BT Fighter AI. We're going to add a Move To task. This tells the AI to move toward the target actor, but placement here is important. Instead of attaching it directly under a selector, we'll place it inside a sequence node. Here's why. A selector stops executing once one task succeeds. So if Move To succeeds first, your attack task might never run. A sequence, on the other hand, executes everything in order, which is exactly what we want. So the flow becomes calculate distance, then move toward target, then attack. You can tweak the acceptable radius on the Move To node. This controls how close the AI needs to get. I'm using a value of around 120, but adjust it to fit your game feel. Then add a small wait task, about 0.2 seconds, just to smooth out movement updates. Now let's talk about combat collisions. For both the AI and the player, I've added collision capsules to key body parts, like hands, feet, and torso. These allow us to detect hits more accurately. To add them, click Add Component, choose a collision shape, I'm using capsules, and attach them to specific bones using the parent socket. Right now, both characters are using the default animation blueprint, ABP Manny. That works for basic movement, but for combat animations, we need something more specific. Our animations use a different skeleton, Fight SK Mannequin, so we need a new animation blueprint. Create a new animation blueprint, select the correct skeleton, Fight_SK_Mannequin skeleton, and give it a name. I'm calling mine Fight Anim Blueprint. Once it's created, open both blueprints side by side and copy over the logic from ABP Manny. Recreate the variables and swap in your combat animations. After that, go back to both your AI character and player character and set their anim class to your new animation blueprint. Now let's fix a couple of important character settings. First, set Jump Off Jump Z factor to 0. This prevents unwanted jumping during collisions. Next, reduce the capsule component radius to 1. This helps prevent characters from sticking together during close combat. For collision presets, set the following: capsule component to pawn, mesh to character mesh, body part collision components to overlap all dynamic. For attack limbs like hands and feet, set them to no collision by default. We'll enable them only during attack animations. Now let's expand our combat system. Previously, we added a single kick animation. Now we'll add more variations, kicks and punches. We'll keep it simple for now, no combos yet. Inside the AI logic, we'll randomly choose an action, like right kick or left punch. Then we'll call a function that selects a random montage from a list of matching animations. Inside that function, add a random integer in range node. Connect it to a switch on int and set the max value based on how many animations you have. Remember, count starts at 0. So if you have 4 animations, your max should be 3. Each output plays a different montage. Now, timing collisions is critical. We only want collisions active at the moment of impact, not during the entire animation. From your montage node, use onNotifyBegin to enable collision. Use onNotifyEnd and onCompleted to disable collision. Set collision to query only when active and no collision when inactive. Also connect onInterrupted to disable collision just in case the animation is cut short. To control when these notifies fire, open your animation montage and add a Montage Notify window at the exact frame where the hit should register. Now let's handle hit reactions. We don't want characters reacting every time they touch, only when they're actually hit. So we'll use tags. For each attacking collision, like hands and feet, add a tag called weapon. Then on the receiving side, select a body collision component, like the chest or head, and add an on-component begin overlap event. From there, cast to the opposing character. Check if the overlapping component has the weapon tag. If true, play a hit reaction montage. This way, only real attacks trigger reactions, not general movement or accidental overlaps. Finally, let's set up player input. I copied the action logic from the AI character into the player blueprint, but instead of automatic triggers, we'll use input events. Go to your Input Actions folder, create a new input action, for example, IA_kick. Then open your input mapping context, add that action, and assign a key or controller button. Back in your player blueprint, replace the AI-triggered functions with these input events. Now the player can trigger attacks manually. And that's it for this part. We now have an AI that can detect, chase, and attack the player, along with a basic combat system using animation-driven collisions. In the next video, we'll build on this and more responsive behaviors.